web app monolith is, and then it's kind of like difficult when we need to switch like the technology stack and try to understand how to run these applications on top of Kubernetes. So during this presentation, my main goal, my main objective is to share pointers about what kind of tools you should be looking at, and what kind of like methodologies and how to make this journey a little bit easier for all of us. So I will be giving pointers. I do not have the time to go in depth on all these things, but feel free to reach out with questions or whatever you think that it's interesting for me to mention as well. So the starting point is a monolith, right? So I've been in my previous experiences, I worked with companies that they had these big Java applications, and Java applications that they tend to grow. We tend to have them in just a single Git repository where all the source code is, and when you try to go deeper into the application, you will see that there are a lot of modules, there are a lot of features that are overlapping, and understanding how that application works is kind of like one of the key points on thinking and redesigning this as a microservice architecture, right? So what we are discussing during this presentation is how to go from having a monolith that have all these things to something more like this. It's just more like a distributed approach where you have different services running. You might end up using containers if you're going towards Kubernetes. So there are a bunch of things that you need to learn. And also the architecture is completely different. The way that you structure the source code, the way that you connect these different services, it's kind of like important. So I did some presentations last year where I show how to, for example, bring CI/CD into your Java monoliths. Even if you have a monolith, having CI/CD, like continuous integration, continuous deployment, and continuous development of this and improvement of this application is kind of important. So I'm running this application inside Kubernetes. I've created a very simple example of a Spring Boot application that you can go there and deploy. I will not be showing this now, but there are I will share some links about those presentations as well. We are now going to talk a little bit about more the things that you are going to find where you're working in something like this. And the first thing that you will notice is that there is no concept of an application here. There are a bunch of services now, so you need to find a way to correlate them and understand how these interactions are going to work. So you might wonder, okay, so how do we start this journey? And again, this journey is not easy and it's not short. So it's not something that I can explain over 50 minutes, but I will be just covering a few things. So this is how the application looks like. I chose to create like an example. I'm a very practical person, so I wanted to code a set of services to represent something like this, right? One of the key lessons learned that I had when I was doing something like this for a different use case is that when you have a big monolith, you will need to choose a set of things to start with, right? Like you need to understand what's the business, objective of the application and what are the core functionalities. For this example, I chose to use like a conference site or like a conference platform to publish different conference sites. In order to start, I decided to create an example of one of these conference sites with a set of modules, right? So the application looks like this. And if I click here in the link, I have that application running in Kubernetes already, in a Kubernetes cluster. So it has like an agenda with 2 days and also a way to submit proposals, right? Like live from JNation. And that's me, and that's my email, right? And here's an abstract, right? I tend to like writing long abstracts. So I can do that, like as a potential speaker, I can do that. And then there will be like the committee of the conference that can go to the back office and accept or reject proposals, right? That's kind of like how it works. If I accept it, I should be able to see that in the agenda. If I reject it, nothing will happen besides sending an email with a rejection notification to the speaker, right? And if I get accepted, I will get an email with that as well, right? So I approve that, and I should be able to see that somewhere here, right? So that's my proposal. It went live into the agenda. Also, I just want to mention here that I have another button here where I can send emails, random emails to anyone involved in the conference, just because it's another feature that I will need in order to communicate with the potential speakers, right? Just to show that it's live and it's running, and I'm not sending an email, I'm just doing a printout in that service where I can just get that email saying, yeah, I got accepted into JNation in this case with my proposal, right? And it was approved by the conference. I will get a similar email if I got rejected, right? And that's running inside the cluster. I'm just tailing the logs of one of the containers. So that's kind of like what the application is. It's like kind of like the use case that we will be looking at. There are a lot of things, there are a lot of angles for this application to cover. So I will get started with how, right? So how do we go in this journey? How do we start? First of all, something that everybody is mentioning nowadays, that Kubernetes is hard, right? And Kubernetes is particularly hard for Java developers for some reason, because we are not used to working this way. We were used to deploy our applications in, in application servers or in server containers. And when working with containers, it kind of like changes the game, right? So first of all, what you need to understand is how to work with Kubernetes. You need to understand how Kubernetes works. And then most importantly, you need to understand how to take your source code that you have in a Git repository into something that is running inside Kubernetes. And that it's kind of like, again, it's a long journey, but there are tools that will help you around that journey, and they will simplify your life. And I will be showing one of those tools in a bit. And also, like the Kubernetes community and ecosystem, it's continuously evolving. So you need to make sure that you keep an eye on how people is using these tools, how other companies are going through this journey, right? You cannot reinvent everything. And the second thing that I think that it's way more important as well, it's that you need to understand your business, right? You need to understand the reason why you're doing this re-architecture, and you need to make sure that it's completely justified. And domain-driven design is one of the things that people tend to recommend to look into, because they provide like some very practical and theoretical concepts that allows you to understand how to do this split, how you can start splitting services, how can you organize your teams, how can you organize your source code, how can you expose well-defined APIs to do things. But let's start with the technical implications, and I will be just mentioning one of these projects, which is Jenkins X. That's kind of like one of the projects that I love. I've been involved with this project for the last 2 years when it was created. And Jenkins X is basically that. It's providing CI/CD for Kubernetes, right? And the whole idea is that the project will allow you to register your source code repository into the Jenkins X installation, and that basically will allow Jenkins X to decorate your project, to create a pipeline, and to run that pipeline to build your project, build containers, and create all the YAML files that you need in order to deploy your service into Kubernetes. So I've been using Jenkins X for a long time, and I've created, as I mentioned before, this example that it's a bunch of services that you can find there in my GitHub account. And let me show you one of these services. Let's see if you can see here. So this repository, it's pretty simple. It's just, again, another Spring Boot application with a POM file and a source directory. And what I did here with Jenkins X is that I've imported this into, I imported this repository into a Jenkins X installation that I have running on Google Cloud here in a cluster. And basically what Jenkins X did when I first imported the project, and again, it was just a plain Spring Boot application, it created a Docker file. It created a pipeline, a Jenkins X pipeline, where the only thing important here is this line, that it's a Maven project using Java 11, right? So it automatically recognized that it's a Maven project because it has a POM file and some Java classes. It created the pipeline. It's based on conventions, so it kind of knows what to do for building a Maven project and then creating a container for it. And finally, it added like the Helm charts. And Helm is a very, very important tool that allows you to package these YAML files to describe how to make a deployment, right? And it uses templates in order to make sure that you can deploy the services into different environments with different values and different parameters. So Jenkins X at this point did 3 things: created a pipeline, created a Docker file to create a container, and then created a package for making sure that we can deploy this into Kubernetes. But it also relies heavily on conventions on how to deal with changes on this repository. So it created some webhooks in order to understand when the master branch changes, and it will automatically trigger pipelines as you are used with normal Jenkins, right? You make a change, it will trigger a pipeline. You create a pull request, it will trigger a pipeline to validate that the pull request is fine. After we made any change in the master branch, we will get a new release. And I think that it's super important. This is conventions. It's best practices all put together onto a tool that you can use, and you can start working in this way. Remember that one of the key points of working with microservices is that you can evolve these services separately, right? So you have one team making sure that they make improvements into the service, and another team working in a different service. they can continuously improve, and you can continuously deploy these improvements. So just to show this, is that something here, I have version 17, and if I show you here the send email panel, I'm using version 17 in here, right? And that basically means that if I go and change the source code for that service, I will automatically create a new release. Usually, I wouldn't do this by changing the source code here in GitHub. I will do it in my IDE, and I will not do it in the master branch. I will create a PR for that. But for the sake of the demonstration, I will just make a change here quickly, just to trigger the pipeline and see how that changes, right? So let's say that I want to change something here in the string that it's returning the version. And I will do that something here, right? So that's pretty much it. That's my change for now. The pipeline will be triggered because I made a change in master. And at some point, I will get like a new release here, version 18, and I should be able to see the change in here. It's important to notice that JenkinsX uses this idea of GitOps, and they have different environments. So as you can see here in the URL, maybe it's small, but I'm running on a staging environment, and I have another environment for production. By default, every time that I get a new version of one of my services, my service and the release of that service will be promoted to staging. That's why at some point, the pod that it's running here, the email service, is going to get restarted, and I will get the new version of that service running in here. We should be able to see that later on during the presentation. For now, let's go back to the slides. So that's all about JenkinsX, right? But again, the big question here is, okay, but how do I know how many of these services do I have? How do I make sure that I split them in a way that makes sense and I'm not over-engineering things or going to micro, right? And that's where, again, DDD comes into help. I will not go deeper into these concepts. There are like books about this, and definitely I do not have enough time, but definitely you should check this, right? So bounded context is that idea of we have a well-scoped set of features that we are going to put together. They make sense for the business to be in isolated in some way. They will expose a well-defined API. It might be a REST endpoints, it might be messages or events, and there will be a small team with domain experts in it. They will build it with domain experts, so domain experts can understand what that piece of software is doing, right? That's in 5 seconds what the bounded context is, but you definitely need to look into it. And this will make a lot of sense when you understand what the business is, right? When you understand what the application is supposed to do, what those set of features are supposed to do, it will be super clear to you what your bounded contexts are. Jumping to the practical side, right? Like not to the conceptual side of what a bounded context is. As I mentioned before, JenkinsX kind of like relies on these conventions of having one repository, one service. And that allows you to have these separated release cycles. So this will allow these small teams of people to just keep working and improving their things. And then, because they are exposing a well-defined set of APIs, will enable other teams to look into those APIs and plan based on these release cycles. Of course, I'm showing you here just again another repository, one of the services that are there, like this is the agenda service. And again, this will work in the same way with different releases and all that stuff. And also using open APIs, of course, I'm using open APIs for this service. So I'm just going into the Swagger UI here, and you can see what are the endpoints that are exposed by the application. And again, because this is in GitHub, you can find how I did that, just adding, just a simple dependency on the Spring Boot app. You will get that, right? So that's pretty much it. Nothing super important, but I think that it's important to understand that if you're working with bounded context and services that have their own release cycles, you will need to share this with other teams, because this kind of like it's some way of your contract to other teams, and this is kind of like what you will need to maintain over time, define what like backward compatibility means for these endpoints and all that stuff. And that takes us to the next concept inside DDD, which is super important, which is context maps, right? So now we have a set of bounded contexts. How do they relate to each other, right? What's like, do we have an upstream or downstream relationship between these services? How they are going to integrate? Who is going to consume what? How are we going to version our APIs? How can we make sure that we don't break everything when we change a single service, right? And on the practical consideration for that side, I think that consumer-driven contract testing, I find this pretty serious and pretty useful in the sense of that if you are not doing this, you should be thinking of doing this and getting this into your projects. So consumer-driven testing is based on Spring Cloud Contract, right? This is one of the frameworks that already implements this. And it's a tool that allows you to implement, to define contracts for your APIs, which can be automatically translated to tests and executed against your services. So if we go back to the presentation, let me show you what a contract looks like. This is a super simple contract. Forgive me, this is kind of like the example is a work in progress. I will keep adding stuff on top of this. But this defines a contract that basically says, we have, this is the call for proposal service. And every time that we get a new proposal, in order to get a new proposal, we need to send a post to this URL with a body like this, right? That's what I was sending via the forms. And this is what I should expect to get back, right? Like in this case, it's just the ID for that proposal plus all the things that I've already sent. And as you can see, you can define variables here just to create the test and to submit data and just to make sure that we get the data back, right? This is defining a contract for the API, right? Like of the fields that we are going to, that we need in order to accept the proposal, the things that are required or not, the kind of data that we are sending and all that stuff. A Spring Cloud Contract allows you to automate this and create a test. So every time that I build my application, my call for proposal application, I will create a test that will start the endpoints, send this data, and expect and assert that this data is back. So we will automatically generate some Java code for the test, and it will run that every time that I build my service, right? And that on itself, it's good. It's a way of testing my APIs from the API's point of view, right? Now I'm just creating a client to send that request, which is super interesting and something that you will do anyways. But what it makes it more interesting for me is that we will create a stub for this. Let me see if I can see this here. What I'm going here is my Nexus. So this is where I'm just deploying all the jars that my applications are creating, right? If you have multiple teams, you will definitely need something like this in order to share your jars if you are into that, right? So what's important here, let me make it bigger, is to see that besides the jar of my application, my Spring Boot jar, I'm also creating something that is called stubs. And this is basically a jar that you can run on its own in order to execute tests against the contract itself, right? So let me go back to the presentation and show you the test. So, and this is super important because at some point you might want to, you will have this problem of I'm building this service A that depends on service B, but in order to run the test of service A, I need to have service B up and running, right? And that's definitely not in a scenario where you want to be, because if you depend on those two things, maybe service B depends on the database, it depends on a message broker, and it depends on a bunch of stuff that you don't want to have running in order to run the test for service A, right? So contracts allows you to do this. They allows you to define this stub, this extra jar that you can make a reference via, like a group artifact and version here. And you can then, when you're running your test for service A, in this case, you can execute a post request against this stub server that it's been automatically started by Spring Boot in this case, right? So this is super, super useful because now in order to test A, you don't really need B. The only thing that you need is the B stub that it's already automatically generated when you define a contract. So that's super interesting. Also, it allows you to understand how versions relate to each other, right? Because the stubs will have the same version of the service. And because the stubs are generated by the contracts defined inside the service, every time that you break compatibility on your APIs, you can quickly know, because tests on other services will start failing with the new contracts, right? And at that point, on service A, which is the one depending on service B, you can start defining on to move to the next version of the contract or to stay with the old version. And in that way, you can start defining the dependencies between these services and these versions. There are some other things around that, around versions, but I guess that will give you kind of like a good idea of that's important. This is something that you should have. And contract testing and Spring Cloud Contract in general, it makes it really easy to use and to consume. So definitely think about looking into these technologies because they will save you a lot of time down the road. But going back to domain-driven design, right? Bounded context and context maps are super useful. But again, as I mentioned before, I'm a very practical guy, so I tend to really like to work with flows, with use cases, right? And this is basically, this diagram here is representing the use case that I showed before. in the sense that we are just representing the steps for submitting a proposal. And then what happens that it's like the committee or the board will approve that. And depending if it's approved or not, what's going to happen. If it's approved, I'm going to send it to the agenda. If it's not approved or approved, I will send a notification to the potential speaker about the decision, right? And this is something that we can all relate. Like I can see this diagram and I can understand it. We can also look at the code for that, which is not the best code ever, but I wanted to highlight a couple of things, right? Like this is not, don't take my coding standards as the best, but just as an example, right? So I wanted to show here that there are two things in this controller, which is taking the requests, right? So in this case, the new proposal one, pretty simple. I have, let's say, a database or a storage where I'm just getting the proposal from the browser and just storing it in the database. Maybe emitting an event for any other system that it's interested in this, this happening. So I received a new proposal. Maybe there is another system interested in reacting on that. You can do that. And the other important one that I think it's where the key logic lives here is the decision, right? Like this is the board decision and what happens after the decision is made, right? So whenever I went to the back office and click accept or reject, I'm just sending to this endpoint. And this endpoint, basically, it's picking up that decision. It's approved or rejected. It's picking up the proposal from the database, let's say. And if the proposal is there, I will just apply the decision, the Boolean, whatever it is, if it's approved or not. I will change the status of the proposal. This is pretty typical. I'm changing the state between these things. The proposal was pending before. Now it's decided. So there is not much more to do. And I'm updating that proposal to the database if I need to. But then here, look at this. So in this case, I'm checking if the decision, if the proposal was approved or not. If it was approved, I will need to call another service, the agenda service, to create an agenda item. And no matter what, I will need to use the email service to notify the speaker via email, right? These two are services that are defined here. And at the end of the day, they are just encapsulating some REST requests. Let me show you that. I think that nothing too important, but just to show that I'm doing a post request into a URL, and this URL is being loaded as that, right? Like by default is that, which is the Kubernetes service name that I'm using in order to interact with this service or this container. And I'm using service discovery there in the sense that I don't know where these containers are. I don't know which port are they running on. The only thing that I know is that I have this string. And if I send a post request to that string, Kubernetes will make sure to arrive to the right container, right? That it's running that service. And again, I'm doing a REST request here, right? So nothing too important besides noticing that I'm using REST template. You can use, the new reactive web client as well, if you want to. So that's the code, right? And believe me, I've done this several times. And, the main problem with this is that, as you can see, the code here, it was pretty easy to understand, right? Like we looked into, for example, the decide definition here, where we kind of like define what happens next. Let's say 10 lines. This, if we send the events and all that stuff, it's just 20 lines max. It's not big, right? But we know Java applications. These 20 lines of code in a year, it's going to be 1,000 lines of code, right? So there are a couple of considerations to have in mind, right? Like when you're building this. And again, the idea here is not to over-engineer, but to be aware that things will happen and that the code will grow and that the complexity will, ended up like making this a little bit more obscure and difficult to understand. And we definitely should avoid doing that, right? And that's kind of like one of the main DDD's, premises there. Like if we need to keep it simple. So first thing is that we have dependencies between services, and that's not a bad thing per se, right? But as you might notice, I'm doing post requests to different services that are running in different containers, and I'm not checking if that's working or not, right? And if I'm not checking, right, like if I'm just letting my calls fail, we might end up in very inconsistent states where I accepted someone, but I never notify them, or the other way around, I notify them that they were accepted, but I never created that entry into the agenda item, right? That's pretty bad, and we need to take care of that, right? And there are different routes. Some of the things that you can do is you can use libraries to do retries. You can use something at the Kubernetes level to do retries for you automatically. That's more like on the infrastructure level. You can use messages. You can use messaging in order to make sure that you have retries on the brokers. And any of these decisions will make your application more complicated. An important side for me, it's like the flow. In this case, this flow that I've showed before, it's buried in code, right? So again, as I mentioned, in that decision method, this kind of logic is where it's created, it's where it's encoded, right? And it's hidden in there, right? It's pretty difficult to expose that to people that it's not coming from IT to understand how these flows look like. Edge cases and unhappy paths, it's what makes basically your code sucks. And when you start adding if else or switches and more logic there to cover these edge cases of what happens if a speaker that looked really interesting completely disappeared, right? We need to start adding more code to check all these things, to make sure that we keep a consistent state, and to make sure that we provide a tool that it's useful for for the people that it's running the conferences. Time-based constraints is more of that. It's like, okay, when you have cron jobs or when you need to have this kind of like alerting mechanisms based on time, right? Like a proposal was created and the board, the committee didn't look into that for the last 3 days. We need to make sure that they are aware that this is sitting there and waiting for a decision, right? And finally, implementing queries and analytics. I've seen this happening a lot of times, right? As I showed you before, every time that we get a proposal, we store that into the database, let's say. And the way that we store that into the database might not be efficient for searching this data or for doing reporting or analytics, right? Maybe for conferences is fine, but if you are going with large amounts of data, it becomes more complicated. What I've seen people doing kind of like a lot of time is sending that to the database and then just storing that, for example, in Elasticsearch to make sure that it's indexed. And if you are trying to do searches like advanced search or full text query searches, you go to Elasticsearch instead of going to the database to get that data. That's kind of like a common pattern that you will find. And of course, in order to solve some of these things, you will maybe try to use one of the existing tools to solve all these problems. And because I've been working on the workflow space for some time, I wanted to just talk a little bit about that. And because I'm also working in one of these projects, it's kind of like good for me to share a little bit about what these tools are doing and how you can quickly use them. So workflows basically allows you to define kind of like the sequence of things to do, and they add some flow control, right? Some kind of like decisions of, okay, if I have this value on this property, I can go that way or the other way, right? Which is pretty relevant for the use case that we have here. And it allows you also to delegate the execution of the business flow to an external component that it's not your service, but your service still defines kind of like what's the flow of things. And by default and for free, they give you like business visibility and continuous improvement, right? You have a quick way to change this flow and these interactions, and automatically data it's going to be exported for people that it's not IT related can see what's going on, right? Like how many proposals are we getting every day, and creating these kind of reports. On the practical side, that's basically service orchestration. And how you do it is you basically have something like a workflow engine that allows you to do this microservice orchestration. That's why I want to talk a little bit about Zeebe, which is a project that was created based on on 10 years of experience on workflows, but with the cloud native architecture. And it's created just to for these like super scalable scenarios. Like in the conference scenario, it's not like that. It's not super big unless you have thousands of conferences happening at the same time. But it's pretty relevant for other use cases like healthcare or Wall Street, like trading, that kind of stuff where you need low latency and high throughput. It's important to know, and this is not specific for Zeebe, but at this point, when you start analyzing external tools, like third-party tools that you're going to integrate with, that you will find them in different flavors, right? Like as a software as a service or on-prem, right? Like you want to have control of the installation and put it like in your own Kubernetes cluster, so the data is still in your control, or you can use a managed service where you just delegate running that thing, that third-party component, to a different company, right? And both have like their advantages. In general, dealing and installing components in your own prem cluster will push you to maintain that and to understand how to, if there are upgrades, how do you do upgrades, and if you need to do data migration, or if you need to move to a different cluster, how you take all the data and move it to a different cluster. So it puts the burden on you, but you have full control of it, right? So you can do both. And in Zeebe, it's both, right? I will be showing a demo of like the SaaS approach, but I could be doing the same thing on-prem on my Kubernetes cluster where I'm running my services. So this is how it looks like when you have like a workflow engine and you try to use one of these tools. And again, this is valid for any other third-party tool that you want to use. But in this case, if you're using a workflow inside the call for proposal service, you will kind of like define what the flow is in a graphical way, right? In this case, we are saying we get a new proposal, we need to wait for a decision to be made, and then we need to choose if it was approved or rejected. If it's approved, I will publish it to the agenda and send, an email to the speaker that it was approved for the conference, or I will send a rejection email here, right? And each of these, blocks at the end of the day will interact with the service, with the real service that is running inside Kubernetes, right? And there is not much to do for that, right? By using a workflow engine like this, again, you define this belongs to this service because it's part of the logic that the service needs to execute, but it's executed outside. It's executed in a different component, which is basically running this thing and also extracting data to Elasticsearch. As I mentioned before, we want to make sure that we have data where we can just run reports and we can understand what's going on from, not from the application perspective, but from, more like a business perspective. So I can use this tool that it comes with Zeebe, and it's called Operate, which basically allows me to see, these flows in a graphical way. And it allows me to see the execution of these flows. As you can see here, I've submitted, 5 presentations before that were accepted and 1 that was rejected. And if I go back to the application, which I have somewhere here, let me see, let me go back. Where is it? Like too many tabs. Probably here, and it's pretty much that. I have like 5 that were approved and 1 that was rejected here, right? And of course, that I can see here, like all the timestamps on each of the instances. I can see the data that it was used and the path that it was taken, right? I can see that it was approved, the status is decided at the end, and I can see in every node when did that happen. And there are some scenarios, let's say healthcare is when you're dealing with the patients and doctors' interactions, you definitely want to have all these for auditing purposes, right? There are some regulations in different industries that requires you to have these kind of things. So that's how it looks when you use a workflow engine. And again, I've done some presentations where I show how to move from the Java implementation to use something like Zeebe in this case. We can take a quick look on the source code for that thing. The application, the master branch is running with that. That basically means that I'm running with the workflow engine here. And you will see that it's not much to just add a client to interact with this service, which is somewhere there. It should be somewhere there. I'm not even sure where I am. I'm in the no workflow thing. That's why it's not there. So it's here in the master branch. It should be there. So we have a client which will connect to this workflow engine that it's distributed. It's running in Kubernetes. In this case, it's running in Camunda's managed service. It's not even running in my Kubernetes cluster. I can see and I can just connect to it by just sending some environmental variables with my credentials. Pretty much it. And then inside the source code, you will see that it's a big change because now I do not call the services directly. So I removed all the services references here because now the workflow orchestrator is going to decide how to do that, right? So this is pretty much what I was showing before. When I receive a new proposal, I store it in the database. But then what I do is I kick a new instance of this workflow, which is what I was showing here in Operate, right? Every time that I receive a proposal, I will have a new instance of this diagram that will go through different paths. Going back there, where was it? Yeah, and then when I want to make a decision, again, I do not make the decision here. I just publish a message saying, yeah, this was decided by the board member, workflow engine just decide what to do next based on the diagram, right? It's important to mention here that we can have different versions of the diagrams, right? So for one of these workflows definitions, I can create a different version to change the interaction, right? Let's say that this is not the right order. I want to send the approval first before publishing to the agenda. Or even more importantly, I want to make a big change, right? I don't want to publish to the agenda unless I have a confirmation from the speaker that he or she is willing to speak in our conference, right? And when they approve that, we want to move forward, right? So I can do that. I can open, this diagram in a modeler, what we call a modeler, where you can easily drag and drop things and move things around, right? So what I will try to do here is I will try to do this live. It might fail as usual, but let's give it a try. So what I'm doing here is I'm adding a new weight wait for speaker confirmation, right? So I have wait for speaker confirmation. I don't want this. I want to make sure that I only do this if the speaker gets approved. And I will just connect that there. So basically now I've introduced a new step that is basically waiting for the speaker to confirm that he or she wants to speak at our conference. I need to define what kind of message and some kind of like correlation, right? Like I need to receive a message saying, yeah, I'm talking about this specific proposal. And I think that proposal ID, this is key in order to work. So basically, I will need to send kind of like the proposal ID in order to say, yeah, I'm confirming that I want to talk about this specific proposal, right? So I made that change. I will save this change. In theory, as I mentioned before, this will belong to the call for proposal service. In this case, I will go here, and I can do, so I'm there. Yeah, so I can do that. In reality, I will just create a pull request to validate these changes. But in here, because I'm doing a live demo, I will just deploy that to the cluster just to get a new version of the diagram up and running, right? And I got version 9 with the changes that I made. So if I refresh this tool, I can see that now I have version 9. And the application by default is configured to use latest version. So that basically means that if I go back to the application here, first of all, we can refresh the application and I can check that I have the new version of the email service. Again, that service is evolving automatically. It's not changing its APIs. That basically means that I can just do an upgrade and I can use the new version, right? I just changed that, so I know for sure that it's working. Again, I'm in a staging environment. This is where you are supposed to find issues if they appear. Also, you are supposed to find issues in the tests, in contract testing. If that's not good, you should be checking into this environment that no APIs are broken. But now if I submit a proposal, live with speaker confirmation, yeah, I will do that, test, right? So I will send that. I will get a new proposal in, right? So I should be able to get that here in the backend. I get that in, and I can see here in my executions, at some point I have that, right? So I'm waiting for a decision, right? Again, if you have thousands of these proposals coming, you will see how many of them are stuck here in the decision point, right? I can go back to the application. I will accept this because it's just a test. And before, I should have seen this here. I'm not seeing it there now because, of course, I'm waiting for the speaker confirmation, right? So this is pretty much what I'm showing. At that point, if you are creating these kind of changes, you will have another service, probably like another form in the website or another section for a speaker to check, or maybe you want to send an email with a link to allow the speaker to click there and say, yes, I'm confirming that I want to participate with this conference. So in this case, I've created like a very, very small service where I'm simulating that link creation, right? So I have a service already running, and here is where I show a little bit of Jenkins X. And I have Jenkins X command line tool here, the one that I'm using for the pipelines. For some reason, I cannot type in this window. That's the screen sharing magic. Oh, damn it. Let me see if something is reacting or if I need to open a new terminal here. New window. Let's see. No, interesting. My terminal is not typing, so it's not allowing me to, there you go, the focus, right? So what I can do now is I can do something like this. I have a service, applications, in Jenkins X, they are called applications. They are like the services that I have running, and you will see that I have the agenda service that I can go and access. When I access and show the open API endpoints, but it's because I was accessing these URLs directly. And I have the speaker service that I have here, which is basically that. It's basically creating a link or having an endpoint where it will receive the proposal ID. And if it receives the right proposal ID, it will just confirm that the speaker wants to speak at this conference, right? So I can do a curl. That's a post, and you can see here the long ID at the end. But because I've just created this proposal, I need to go and grab the ID, which is basically, if you're going to send an email with that, you will have it already, right? So what I'm doing here, I'm just copying this ID, and at some point, this should just notify that the speaker is confirming the participation on the event. So it's confirmed. If everything is working as expected, at some point it should move. Believe me, if it doesn't move, well, something failed. But yes, it moved and it sent an email, right? So that's how quick and easy it is to make a change. And again, going back to things that you can do with these is more advanced stuff, right? Like that's a pretty basic change, but you can do stuff like, for example, adding a timer here. So we can add a timer, and that timer can say after 2 days, if I didn't hear back from the speaker, I will send another email, right? Email reminder, right? And if this gets completed, this timer is canceled, of course. But if not, I will send a reminder every 2 days or something like that. I can create another timer to say after 10 days, if they are not answering, I will just send a rejection because I need a timeout, right? Like I cannot wait any longer for you. I will just reject your proposal because you're not answering my emails. That kind of stuff. And that's pretty powerful because in order to create that timer, you don't really need to do anything. At that point, you are delegating everything to this external component that is dealing with these timers and also reporting everything back to this, to Elasticsearch, which can be, graphically seen in this operate tool. So that's kind of like the demo that I have for today's session. There are a bunch of takeaways. In general, Kubernetes is hard, right? And again, I'm not trying to say that with this, you will solve all the problems that you have. But what I'm trying to say here is that you will find different tools and you will need to optimize your decision-making process around what to build yourself. Like in the case of this, you don't want to build a workflow engine for sure. You want to use something that is already existing. And then you need to understand how to integrate with it, right? In these very polyglot environments like Kubernetes, where you can just run containers that are written in any way, you will heavily rely on their APIs and on the version streams. And on the other hand, I want to, again, make it clear that you need to make sure that you focus on business value, right? So again, why are you doing all these changes? Why are you making this big re-architecture? It definitely needs to make some sense for your business. And feel free to reach out to me via Twitter if you want to follow me on Twitter. And I'm also working on this workshop, kind of like guide, that it's called From Monolith to K8s, where I show you how to run all these examples in your infrastructure, because I believe that by running things and by looking at projects that are already working, you will have a way much easier life on deciding which tools to use or which frameworks to use and how to apply contract testing, for example, for your projects. It's super open for contributions, so feel free to reach out, and that's pretty much it, my presentation. If you have any questions, please feel free to reach out.
Thank you very much, Mauricio. Great talk. We have a couple of questions here on Slack from the guys. Jonathan Villa, I'm gonna read like 2 questions at a time and go over them.
I think that I know Jonathan. Let's see.
So yes, the first one is, Mauricio, you have talked about DDD and link it to microservices. So everything must start from that DDD approach and see if our bounded context team's definition leads us to microservices or to monoliths. And the second one from Jonathan as well is, Mauricio, could we agree that monoliths have the complexity of the code, and moving to microservices, we move that complexity to orchestration, traceability, transactions, etc. And we have to take very carefully this decision.
Yes, totally. So we agree on those 2 points. I think that, yeah, we totally agree with that. So if you are heavily on DDD, yes. So you need to make sure that you do that first. Some people, it's a little bit more practical. They just try to see how it goes. And based on their experiences, they make the right decisions to make the projects work. I tend to agree that we are switching the complexity from the monolith to the infrastructure a little bit. But there are some cases where that's completely justified, right? If your application wasn't scaling enough and you needed to re-architect some pieces to make sure that they work, massively in large-scale systems, that's the only way to do it. It's like you cannot escape with a single monolith. Of course, that there are trade-offs, and as I think that I mentioned several times during my presentation that this is kind of like a complicated journey. It can be done. The tools are getting better and better, but you need to be aware of that.
Yeah. So we have another question here from João Rebelo, and he says, I assume Zeebe would support compensation actions to support transaction failing in the process.
Yes, so there are a couple of things around that. So there are a couple of things about transactions in there, right? Something that I didn't show is that every time that I'm executing, one of these service interactions, there is like a pub/sub mechanism where basically you can interact that with retries. So there are it's definitely, yeah, so you can definitely implement compensation there, not on the diagrams just yet. That's something that is coming along the ways. But not yet like on the diagrams. I guess that's why he's asking. But definitely you can implement compensations on retries. And also like the graphical tool allows you to quickly see when something went wrong. So you can see, okay, that service was down for more than 3 retries. So you can just go and schedule another retry when you know that the service is up and running again. I didn't show in my demo either that if all the services are down, the orchestration engine will know and it will wait until the services gets back up in order to start the execution, which is kind of cool and something that you get out for free there. And if not, you will need to implement that with different things.
Yeah. So we're running out of time, but we still have another question here from Gonçalo Silva. Yep. He asks, does Zeebe support some form of transaction between multiple services, like distributed Saga?
No, yeah. So you can implement the Saga pattern with Zeebe, and there is a blog post about that. I will be creating a blog post and sharing that blog post with my presentation and the links to the examples, and I will link the Saga pattern implementation with Zeebe. When we talk about distributed transaction, it is a pretty complicated, discussion about how do you implement that. There is no distributed transactions in Zeebe, but the orchestration engine is keeping track of what was executed and what not, right? Which is something that if not, you will need to do again with the distributed transaction framework or something like that.
So I guess we are out of questions. We're also out of time. So a big thank you to Mauricio, and we hope to see you back here at Generation 2021, hopefully on site and not on Zoom. But a big thank you, Mauricio. And guys, grab a quick coffee or a quick snack, and we'll see you back here in about 5 minutes or 6 minutes, actually. See you later, guys.
Thank you very much.